Today we have to discuss about some problems on magnetic induction. Okay, the first problem is when the current through primary coil decreases from 2.5 ampere to 2 ampere in 0.1 second. The EMF induced in the secondary is 3 volt. Calculate the coefficient of mutual induction for the pair of the coil. So first you have to read this problem very carefully and write the given data. What are they given here? And they given here the EMF induced in the secondary coil, that is epsilon is 3 volt, and the primary coil decreases from 2.5 ampere to 2 ampere. So you have to take I2 minus I1. So I2 is and I1. So I2 is 2 ampere and I1 is 2.5 ampere, and they given the time at 0.1 second. So you know that the coefficient of mutual induction, that is induced EMF induced is epsilon equal to minus m into di by dt. Okay, here epsilon is the, put the value, epsilon value is this, epsilon is 3 volts equal to minus m, and here di by di is nothing but I2 minus I1. So m into I2 minus I1, that is I2 is 2 minus 2.5 divided by 0.1 dt, change in time they given, and here m here minus 0.5. So 0.5 divided by 0.1 is 5. So m into 5. So therefore coefficient of mutual induction, so m is equal to, you send this 5 on this side, at that time 3 divided by 5. So 3 divided by 5 equal to 0.6, and the SI unit of mutual inductance is Henry. Next problem is the magnetic flux threading a coil changes from 10 into 10 to the power minus 3 Weber to 2 into 10 to the power minus 3 Weber in a 0.01 second. Calculate the induced EMF. Okay, now you have to calculate the induced EMF. So what are the given data? They given the change of magnetic flux 10 into 10 to the power minus 3 over to 2 into 10 to the power minus 3, and they given the magnetic flux phi1 and phi2. So how much phi1 is? Phi1 is 10 into 10 to the power minus 3 Weber, and phi2 is 2 into 10 to the power minus 3 Weber, and they given the time, how much change in time, that is 0.01 second. So now induced EMF is equal to, so epsilon equal to minus d phi divided by dt, and d phi is nothing but, therefore d phi is nothing but equal to phi2 minus phi1. So you know the phi2 value and phi1 value, you have to substitute here. So equal to minus phi2 minus phi1 divided by dt, and phi2 is 2 into 10 to the power minus 3 minus 10 into 10 to the power minus 3 divided by 0.01. So equal to, you substitute this one, you will get the value 0.8 volt. Okay, this is the induced EMF. Problems on magnetic materials. So calculate the permeability and susceptibility of a magnetic bar of a cross section 0.1 centimeter square having magnetic flux of 2.41 into 10 to the power minus 5 Weber due to magnetic intensity of 3200 ampere per meter. Here they asked the permeability and susceptibility of a magnetic bar, and now you have to write the given data. So they given the magnetic intensity here. So the magnetic intensity 3200, magnetic intensity is H ampere per meter, and next they given the magnetic flux. Magnetic flux is 2.41 into 10 to the power minus 5, and they given the area of cross section. Area of cross section here 0.1 centimeter square. So you have to convert into meter. 0.1 into 10 to the power minus 4 meter square, and then you have to find out the relative permeability. So permeability is B divided by H, but you know that B equal to 5 by A. So the magnetic field, is nothing but the magnetic flux per unit area, and so mu equal to, you have to substitute B value here, 5 divided by HA, and you have to put the values here. So the 5 value is 2.41 into 10 to the power minus 5 divided by H value is 3200, and next A value is 0.1 into 10 to the power minus 4. So if you calculated this one, you will get the value 7.53 into 10 to the power minus 4. So SI unit is Tesla meter per ampere. Okay, this is the permeability. They given the susceptibility of magnetic bar cross section at 0.1 centimeter having a magnetic flux of 2.41 into Weber due to magnetic intensity of 3200 ampere. And next problem is a paramagnetic substance of a susceptibility 4.10⁻⁴ is placed in a magnetizing field of 6 into 10 to the power 4 pair per meter. Calculate the intensity of magnetization and relative permeability. So they given the paramagnetic substance of susceptibilities. So susceptibility is 4 into 10 to the power minus 4, and next they given the magnetic field of 6 into 10 to the 4 ampere per meter, and nothing but it is H 6 into 10 to the power 4 ampere per meter. Next they asked the intensity of magnetization and the relative permeability. So first one, we know that the intensity of magnetization. So intensity of magnetization, note that magnetic susceptibility is M divided by H. So M equal to X and X into H. So we know that X value and H value. So X value is 10 to the power minus 4 and H value is 6 into 10 to the power minus 4. Okay, sorry, this one is the first one. And you multiply it, you will get the 24 ampere per meter. And next I have to find out the second one, relative permeability. So relative mu r, so mu r equal to 1 plus x, that is 1 plus 4 into 10 to the power minus 4, you will get the 1.004. This is the relative permeability. So here they given the placed in a magnetic field is nothing but a magnetic intensity. So 6 into 10 to the power ampere per meter. And here they ask the intensity of magnetization and relative permeability. So intensity of magnetization, here we know that the susceptibility and the magnetic intensity X equal to M by H. So take H on this side, M equal to XH. So multiply, you will get the intensity of magnetization. Relative permeability mu r equal to 1 plus X, and you got the value 1.0004.